So let's talk about some issues that come up with object-oriented programming in programming languages. So if you have multiple inheritance, one classic problem is the problem of is the diamond problem. So the idea here is that we have some class D that implements from both B and C, and in some versions of the program of the problem, B and C both also inherit from A. And so the setup is that all three of these classes implement a method called foo. Well, the question is, well, if we call foo from a method that is in D, which version of foo do we get? So there are, three potential answers to this. It could be B's foo, it could be C's foo, or it could be A's foo, and it's not immediately obvious which of those is the correct answer here. So the way that C++ resolves this is that it uses the ordering from the definition. So because B is listed first in the inheritance list, then you'll get B's version of foo if both B and C have foo. Java's original solution to this was to completely disallow it by not allowing multiple inheritance. So basically, one of B or C here would have to be an interface, not an actual not an actual inheritance, inheriting a class. So there either wouldn't be a foo, or there would only be the one foo from whichever one of these was not an interface. More recent versions of Java have actually reintroduced this problem, though, because they've added default methods for interfaces. And so if you inherit two different interfaces with the same default method, or different implementations of the same default method, then you'll now get a compiler error. Another problem with inheritance is if you have uh, things that are allocated and you are converting from subclasses to superclasses, then you get something called object slicing, where you lose the members that are associated with the subclass, and there's no real way to get them back. There's also the problem of how do you support polymorphism. This allows you to implement things like abstract data types, which you may have done in 240. So in C++, there are these things called templates that allow you to genericize a definition. So you say template class T, and so then anywhere inside of this definition, T can potentially be any data type. And so what C++ actually does at this point is if you have a template, you have to instantiate the template at some point with a particular type, and you can do it with multiple types. And so C++ will just compile multiple copies of this code, one for each type that the template has been instantiated for. Java handles this slightly different. So Java calls these generics, and they look a little bit similar, but the implementation is very different in that Java doesn't compile different versions. It actually just uses something called type erasure, and it changes the type to object, and basically makes the data structure completely generic, and it inserts a bunch of runtime casts, which are very expensive. And so what this means is that there's actually no runtime difference between a hash set of strings and a hash set of integers. And this can lead to some confusion, as you might imagine. All right, and this can also cause a problem because there's only one set of static member data. The last concept here is the concept of reflection. So this addresses the problem of, well, can you extract information about classes and inheritance and methods at runtime? So a language with reflection provides runtime access to the type and structure metadata, sometimes with the ability to modify, sometimes not, but often this incurs a severe runtime penalty because you have to be able to keep track of all this data. So we saw this in Ruby because we were able to take an object and call the methods method on it, and that gave us a list of the methods. And there's also a send method, which if you have the name of a function, you can use the send method to invoke a particular method. So this is an extremely roundabout way of calling upcase on hello. So we grab a string, we get the methods, we look through it for upcase, we find the first one, and then we take that and we send it to hello. So again, you would never want to do this, but this illustrates that this is possible. And again, this introduces a lot of runtime overhead into the language because it has to maintain all of these data structures. Incidentally, you can also do this in Java using the class and the reflect information.